Okay, this lesson is going through function notation. So I have here a function is like a machine where we input x values and output or produce y values. Every x value only outputs one y value. That's like in the last lesson. When you graph it, every x value only corresponds to one y value. So like, what is this diagram? It's like you've got a x value, you put it into the function, it does things, it might square it, it might multiply it, it might do all sorts of things. And then the answer that you get is the corresponding y value. So function notation, now we are used to equations of the form y equals 2x minus 3. That's what you're used to using. So for instance, if we input x is 1, we get y equals negative 1. So for instance, if I go y equals x is 1, so it's 2 times 1 minus 3, it does become negative 1. So because I just want to explain, this x value that we put into the x coordinate, that's the input, and the value that we get in the end is like the output or the y coordinate if you were going to plot the point. So we can also write the same function using this f or function notation. So here, y equals fx. That's really important. I want you to realize fx is also like another name for y. It's what the function does to x to get y. So we can rewrite the function as fx equals 2x minus 3. That's the main one we use. So to do what we did before, if fx equals 2x minus 3, then if I want to sub in 1 for x, it's like I'm saying, oh, f of 1. So what have I done? I've replaced x with 1, so I need to do the same thing in the function. So it becomes 2 times 1. So x becomes 1 minus 3, which again is negative 1. And notice that back here, y was equal to negative 1, whereas here, f of 1 equals negative 1, but that is the same as y. F of 1 gives the y value of the coordinate, so all of that corresponds to the coordinate. X is 1 and y is negative 1, so if you were plotting it, that would be the point you would plot. And another type of fx notation is this one here, this one here, f dot dot x, it's like this is saying kind of becomes 2x plus 3. That's only occasionally used. The first one is definitely more common. So, first question, if f dot dot x becomes 4x squared minus x, find the value of f of negative 2. Now personally, while we're getting used to it, I would rewrite this first into this fx notation. I want you to understand that that can be rewritten as f of x equals 4x squared minus x. And I'd probably encourage you to rewrite like that in this notation all the time whenever you see that first one, because I think it's just easier to understand. So, in that case, f of negative 2 would equal, now remember, we've replaced x now with negative 2, so I want you to do that again anytime you see x. So it becomes 4 times negative 2 squared, and make sure you put that negative 2 in brackets so you square the negative part as well, minus, I'm going to use brackets again even though I technically don't have to. I'm just going to emphasize the brackets. So I've replaced x with negative 2. And then I work that out. That becomes 4 times 4, and that becomes plus 2, which is 18. So again, I want to stress that if you were to draw this function, that becomes the point. Okay, so x was negative 2, and the value we got in the end was 18, so that's the y value. So that's the x value and that's the y value. You don't have to write this out for this question. I'm just trying to show you the relationship. Okay, so hopefully it's making sense. Now, you know what, before we do this next one, I might do another one. So girls, I'm going to make up another question now. If fx equals, x cubed minus 3x plus 7, find, let's say first f of a. That looks weird, but it's actually just replacing x with a. That's all you have to do. So just think whatever is in here is what I replace x with. So it becomes a cubed minus 3a plus 7. And because a is not a number, I can't simplify that anymore. What about, I'm going to make up another one. F of, say, 2k. Okay, it looks hard, but it's not. Again, we just replace every x with 2k. Okay, so here we've got x cubed, so this time I want to do all of 2k cubed. And then we've got minus 3 times x, so it's minus 3 times 2k. And then we've got plus 7. Well, that's not a problem, it's just plus 7, because there's no x in this part, so it doesn't need to change. I don't need to put in the k anywhere. So now and I get 8k cubed minus 6k plus 7. And I can't simplify that anymore because there's no like terms there. So I just wanted to do a couple more examples with you first. And now let's go back to this one here. It says, if fx equals x squared minus 3x plus 1, find in simplest form f of x minus 2. Now that looks confusing, but again, we're literally just replacing the original x's with x minus 2. So f of x minus 2 equals, if x is being squared, then we get all of this and square it. So it's x minus 2 squared minus 3 times all of this, x minus 2, and then plus 1. So just think of it like we thought of the a and the 2k. It's the same thing. You just grab all of it and do whatever's being done to x. If x is being squared, you square all of this. If x is being multiplied by 3, you do the same to this. Okay, that's all you need to do. So again, I want to explain this again is just input, and we just do to it whatever the function is telling us to. So what is x minus 2 squared? Hopefully you know it's x squared minus 4x plus 4. And then I multiply that out and I get negative 3x plus 6. And then I've got the plus 1 at the end. Here I do have some like terms, so I can simplify it. And it becomes x squared minus 7x plus 11, I believe. And that's it. So it's really quite a simple thing. It's just a bit different than you're used to from year 10. So girls, I recommend doing exercise 2B now to make sure that you understand the concept. So at least doing some of that. Thank you.